Good. I wanted to ask you about the registration time.
Right. Okay.
Since Ted looked me up and talked about the implementation I did, but I implemented something that's very similar, but there's a few differences. One of which, where I wanted to ask you, why the date lease? So I just overloaded the TTL of what in the registration. The TTL is interpreted as this is how long I'm around until I get away.
That's a good question. When we originally did this,
Hello? Ah. We don't seem to have an area director, but I'm not sure we need one.
I can tell you a script. You might find it flat to figure my address on that example.
I guess I'll go ahead and start. Hi, everybody. So, I believe we're supposed to be starting now. So, and we only have an hour. We have a number of presentations, so thought I'd go ahead and get underway. Okay, yeah. So I'm Donald Eastlake with Huawei, and
Russ White, LinkedIn.
So we're the co-chairs. Leah Atlas is the area director. She's not here right now. This is the basic information. These slides are all available for download. People should note the note well, the IPR requirements. I'd like to request people to review documents when we call for that, so that we'll get higher quality documents. And if you have documents you have that you want to get through, it's always helpful to review other people's documents, because then probably they'll review your documents. So this is the current agenda. We do want to have somebody to take notes, somebody to be Jabber scribe, and at least convey any. Great, thank you. Okay, I believe Russ is doing some stuff there. So we have blue sheets for people to record their attendance. Okay.
That would be an amazing idea.
So do we want to start that one around, or do we just have one?
No, we just have.
I guess it's just one set going around. It doesn't seem to be that huge a throng of people here today.
If we run out of slots on the blue sheet, please let me know and I'll start the second one. There's only like 150 slots on the blue sheet or something. So
I could have them, but I don't think this meeting, perhaps.
There's 116 slots. If we run out of slots.
Okay, so just going to just talk about the status a little bit and milestones, and then go through we have a pile of presentations. So this stuff adds up to about an hour. So we can't generally, if we go over on one thing, we'll have to go under on something else, generally speaking. Mandatory sub-TLBs, general protocol from Julia's, unicast to lows, information model, beer and Babel, and source-specific routing. Anybody want to change something around, or add or delete, or reorder, or anything? Okay. So there's basically a couple of working group drafts. The Babel applicability draft is actually expired. It came up for expiration during the refractory period when you can't post before the IETF meeting. And there's the main protocol draft, RFC 6126 bis. So The applicability draft has actually been in working group last call for a while, and there really weren't hardly any comments, and there was a review. The review needs to be responded to, so chairs have decided, we'll just declare that to have not passed this working group last call, needs to be revised and reposted, and we'll do a working group last call on it in the future, possibly at the same time as we do it on RFC 6126 bis. We'll see what the discussions on the main protocol draft reveal at this meeting. There is a HomeNet Babel profile draft, and there's a series of personal drafts at the bottom here. So there are presentations. Actually, this is out of date. The Babel information model draft is a working group draft now, as we decided last time. So I'll update this slide. It should be listed up at the top rather than draft Stark Babel information model. It should be said draft IETF, and that should be up at the top. Sorry about that. And there were this previous series of 3 informational RFCs. So milestones, we actually have the third item here should also be in green because we did adopt that. So we're actually not formally behind, but it seems like we will not be submitting these drafts to the IESG this month. So we're a bit behind on these later milestones. Unless there's some questions, we should proceed with the presentations.
Did you delete your pen? I don't know why I still need to email URL.
So that would be.
The links straight off the HTML agenda.
Yeah,
It's
that's
not
what
Word 9000 anymore, and it is HTTPS. So if you're typing stuff in and get auto.
No, I just use the link directly off and it just doesn't. It says this doesn't exist. All right, I'll try without the port 9000.
9000.
Yes.
Go ahead.
Just in time.
You can go ahead.
Yeah. Hello, I'm Julius Krawacek, and I'd like to tell you about some recent extensions to Babel, and most notably mandatory sub-TLVs. Next, please. So I believe that you all know that one of the goals of this working group is to create a successor to 2 documents, the Babel base protocol, which is 6126, which was written in 2011 and experimental, and 7557, which defines the Babel extension protocol, and which was written 4 years later. And one of our goals is to merge those 2 documents and produce a merged document that is better than either of the original documents, and it is standard track. Next, please. So basically, the protocol remains the same. 6126 bis is the same protocol as 6126. You did like Babel, you'll probably still like 6126 bis. We've made 4 substantial changes to the protocol. A lot of editorial changes. The document reads, I think, much better than the old documents, but we've made 4 substantial changes. Mandatory sub-TLVs, which have been implemented, which I feel very comfortable with, which are an incompatible extension, and that's what this talk is about. Unicast hellos, which I'm not sure about the implementation status of. At least I haven't seen the implementation, which are an incompatible extension, and that's what David is going to speak about.
Hey, David Skenazy, just to clarify that question mark, we have so far one well, I know I have one. I think Tokyo may have one as well, but we haven't done interop yet. We're thinking of doing it this week.
Okay.
All right. We have 1.5 implementations.
Okay, I'm always dubious about fractional implementation.
It's an implementation, but it's on something different.
Okay. And there are two places where I've significantly relaxed the protocol, given much more freedom to the implementer. In both cases, I've been careful to make sure that if you obey the old specification, you're still compliant. That's root acquisition, and that's been implemented for ages. Actually, the reference implementation was optionally with the right flag, violating the old protocol. So now I want to make this behavior the default. That's perfectly compatible, and I would like people to help reviewing that. The section of the document is called root acquisition, and we very recently found a way to relax the hold time requirement. We believe that is compatible. We believe it works. It was unimplemented when I wrote the slides, and since then I've met Matthew in a corridor who told me, by the way, it's implemented now, but I don't know if it compiles. So we hope we're going to check it soon. And that is an important extension for reasons I won't have time to get into. Please review and implement and tell me if it makes any sense. And you see that there are two big red incompatible here. I'm going to come back to that later. Next, please. Okay, so to remind you, a Babel packet contains a bunch of TLVs. TLVs have a type, a length, and a body. And 6126 says, if you see some extra data at the end of the body, please ignore it. Just pretend it didn't exist. And that place was for extensions. At the time, I didn't know what extensions would look like, and in 7557, I defined, once they had been implemented, what extensions look like. Sub-TLVs, which have a type, a length, and a body. They have exactly the same structure as TLVs, and you just dump them at the end of the TLV after the body. And if there's a sub-TLV you don't know about, you just pretend it wasn't there. Next, please. Now, sometimes if extension data is not understood, you want the whole TLV, not just the extension data, to be ignored. And you cannot do that with 7557 sub-TLVs. And so, to avoid this issue, the source-specific extension, which I think is the most important extension of Babel, which is due to Mathieu Boutier, who is sitting over there, uses 3 new TLVs, which mirror the update, the request, and the SecNo request, which are called the source-specific update, the source-specific request, the source-specific SecNo request, so that the whole TLV will be ignored by implementations that don't understand the extension. Next, please. Now, so you cannot do that with sub-TLVs, and what I suggested, I think it was Chicago, was to use a new address encoding. Think a new address family, if you don't know what AEs and Babel are. And a new AE will be silently ignored by existing implementations. And the working group was polite, because this is a polite working group, and they received the idea, I would say, somewhat cautiously. And so to prove that I was right, I asked Mathieu and Gwendoline Schwan, who is not here today, to show that I was right by implementing source-specific routing and TOS-specific routing, respectively, using a new AE. And the problem when you ask your students to prove that you're right is that sometimes they prove you're wrong, and that's what they did. Defining a new AE was an absolute mess. And I put the gory details written in a polite manner in Appendix C of the document. Next, please. So, what Mathieu and Gwendoline convinced me of, although I was kicking and screaming, was that we need a mandatory bit. So in 6126 bis, if a sub-TLV has a type bit with the most significant bit set, that is a type between 128 and 205, 255, it is mandatory. And if you see an unknown mandatory TLV, a sub-TLV, sorry, you drop the whole enclosing TLV. And what Mathieu and Gwendoline have shown, that works beautifully for source-specific routing and for TOS-specific routing. And both extensions are implemented, they have been tested, and they have been written down in internet drafts. Next, please. Now, there is one technical difficulty, which is that Babel uses a stateful parser. When you parse a TLV, you retain some data, and later on, a TLV can refer to this data. It's a fairly simple procedure that allows saving, in the case of IPv6 networks, a good 8 octets per prefix. And so that's very useful. And unfortunately, because you have the state, you have to maintain the state. So you don't entirely ignore a TLV that has been suppressed due to an unknown mandatory sub-TLV. You still update your parser state. In other terms, parsing does not depend on which extensions you implement. A packet always gets parsed in the same manner, and if you're not convinced that's essential, think about TCP dump. It's not defined what kinds of extension TCP dump implements, and you still want TCP dump to be able to parse a Babel packet. Next, please. Okay, so what complexity does it add to the implementation? So the main difference is that now you have to parse sub-TLVs no matter what. Even if your implementation doesn't implement any sub-TLVs, you still must parse sub-TLVs in order to check whether there are any that have the mandatory bit set. And an example of an implementation that doesn't do any sub-TLVs is sBabel-D. The S stands for stub or simple or stupid or whatever. And this is an implementation that was written just to show how small an implementation of Babel can be. And this implementation, when I implemented mandatory bits in it, grew by 38 lines of C. That's basically 30 lines of the sub-TLV parser and a few calls to it. And the binary size increased by 56 bytes. That's bytes, right? Next, please. Okay, but mandatory bits are incompatible with RFC 6126. Old implementations will not ignore TLVs that contain unknown mandatory sub-TLVs. And in principle, this could break your network if you're not ignoring the TLVs that you don't understand. The same is true of unicast hellos. And now we need to make a choice. One possibility is to say, well, if mixing 6126 routers with the new extensions breaks the network, just don't do that. Okay, so before you insert a TOS-specific router or a source-specific router into your network, make sure that all of your routers have been upgraded to the new version of the specification. The other possibility is to bump the protocol version on packets that contain, to bump the protocol version. The protocol version is currently 2, we could bump it to 3. And the problem is that for many of our users, a flag day is just not possible. So this could be done without imposing a flag day by simply saying, continue sending packets of version 2. But if you send a packet that contains any mandatory bit, then this particular packet must be version 3. In other words, you will still be sending packets of version 2, and just on occasion, when you're deployed the new extension, sending packets with version 3. Tony?
So I don't know whether you have this solution, and it's not that easy with the distance vector, but you could stick now a new TLV on every router, propagate it across the network, and then you would understand who understands mandatory and who doesn't. And you could avoid the guys who don't understand mandatory.
So basically a capability.
Yeah, exactly. But with DV, it's not that simple, but it works fine.
So what I'm suggesting here is pretty similar. It is simply that you use this version number as the capability. So version number.
But observe that the version number will, at certain point in time, ruin the guys who don't understand the new version number. If you stick a new TLV, they will just ignore the TLV, and the new guys will understand, oh, the capability means if this guy doesn't advertise it with this capability, I have to avoid him because he does not speak the version. Mm-hmm. There is a subtle difference there.
Yeah, there is a difference. Mm-hmm. So down there is the wording that I'm proposing if we decide to do that. Perhaps I will conclude because the next one is my conclusion slide. Next, please. Yeah. So mandatory sub-TLVs are a simple, elegant feature that drastically simplifies at least 2 extensions to the protocol, at least one of which is actually something that people want to use. They're incompatible with the old spec. They can break your network if you enable the new extension without upgrading your old routers. And this could potentially be avoided by bumping the protocol version. Thank you for your attention.
Thanks, Joyce. David Skenazy. I really dislike the option of bumping the protocol version. So first point is I disagree that we need a flag day. You can have two separate ones, as you actually discussed, if memory recalls, in Chicago. First, you do away of where everything supports the mandatory bits and just drops those, and also supports the unicast hellos and drops those. And then many months later, you can update the routers one by one to start sending these. So that is one solution. You don't need a flag day, which means you flip the switch for anything on at once, which makes it a lot more bearable. If you could go back one slide, please. You propose two solutions. So the first one I think could be doable if we have those two separate days. The second one, well, there's also a third possibility, which is all RFC 6126 is version 3, period. I don't like it either. It's still a possibility that is still doable. But this one, honestly, it's going to become a mess of remembering, wait, I have one that supports version 2 and one version 3. Wait, that one showed up. I can do v3 now. Well, wait, I have to go back down. It sounds like a terrible headache, and we tried to avoid capabilities in Babel.
It's actually much simpler than that. What the spec says is that you must accept packets of both versions. So where you have your if version different from 2, you put if version different from both 2 and 3. So on reception, you just have 2 versions that you accept. On sending, you're allowed to always send 3. But what is recommended is that you send 2 unless you've put a mandatory bit somewhere. So it's actually much simpler than you make it.
Well, if I start sending some packets with version 2 and some packets with version 3, and I just do that when I'm like writing the packets, and I just say, oh, was one of those in there or not, I think you can construct a scenario where you end up breaking the guarantees of loop avoidance of Babel because you're telling something to one node that you're not telling the others. I'm not entirely sure on that. I would have to build an example.
No, you can create black holes, but not routing loops.
Sorry. Are black holes okay?
I'm just basically going to agree with David, but I'm going to point out that unless RFC 6126, not BIS, the original, says that what you're supposed to do if you get a higher version number is throw out that packet and do nothing at all to the state of that that peer, I don't know if we know if existing implementations, when they got a version 3 suddenly and they only implement version 2 from a peer, are they going to just keep it state alone?
The exact sentence in 6126 is packets with a version number different from 2 must, capital must, be silently ignored.
Okay, and so the rest, so it should work.
Which doesn't
then
say anything about what the implementations do. That's what the spec says.
Well, yeah, I mean, but, you know, are you fairly confident that what we have is implementations that would just ignore that one packet and would not assume anything about the peer?
Yes,
Yeah,
because
okay.
that's a fairly simple requirement here.
Michael Richardson. So I'm not really enthusiastic about the version 3, version 2 stuff. What happens in version 4?
It is silently ignored.
Right. What happens to all the, so just be clear, so we need to keep carrying around all the I must send version 2 code. If I don't have any mandatory sub-TLVs, I should send as version 2, right? So what happens when we go from 3 to 4? Do we still send as version 2 and everyone keeps all their version 2 parsing code around?
Okay.
Yeah, I that's why I don't like it. So that's the reason. And so I think that figure something else out. That's what I would say. Yeah, maybe like the business of you've heard a version 3 packet from or you've heard a TLV that says I speak sub TLVs and therefore I'll send them from another device. That's as good to me as anything else.
You're allowed to send packets over multicast. So you
Right.
cannot select which neighbor
No,
you
I'm
send
saying
it.
if I have heard from peer X this TLV that says I speak the new TLVs, then I remember that when I unicast to them, right? That seems better to me than remembering that they're a version 2 or something.
Turkey Highland Jackinson. I agree with all the people who say that that this is annoying and too complex. But I'm also not sure whether or not it solves the problem, because we have widely or relatively wildly deployed extensions that now exist in 2 different versions. So at best, for example, the source-specific extension exists in a version that would be compatible with version 2, and one that depends on sub-TLVs. So if you deploy new routers with the new version, then they're not going to speak source-specific with the old ones.
They will only exchange non-specific routes. That's correct.
So I'm not sure it solves the problem. Then you have half a network. It may not fail as catastrophically, but I'm not sure the complexity is worth the gain in what we actually achieve.
That looks to me like a consensus.
You're allowed to be part of the consensus as well.
Okay, so are there further, if not anymore, I perhaps even should have cut that off a little earlier. This seems like a very important point to discuss, but we have quite a few presentations, so I don't know what we need to go any further on this right now. So
This is a very cramped pink box again. All right. Hi, everyone. My name is David Skenazy. I work at Apple, and I've been playing with Babel for a few years now, or well, maybe at least a year. Anyway, I'm here to talk about unicast hellos. So this is work in collaboration with mainly Toki and Julius, who spend a lot of time like either writing code or the doc, but also with a bunch of other people that contributed to the document or on the mailing list. Apologies if I forgot anyone. Also, none of the names listed here, apart from myself, or almost none of them, read the slides yet, so they can't be held responsible for any mistakes in them. All right, next slide, please. So the main reason I got interested in this is when I wrote my first implementation of Babel, one of the links it was running over was some custom wireless link that would TDMA between frequencies. And one of the properties of that is that multicast was a disaster. Unicast you would get reliably because you knew when the other peer was listening. Multicast, not so much. And so I was kind of, in this case, this wasn't my implementation, it was the original one. And it was just, it kept falling over. So I went and dug up into it and figured out that it was because of the multicast. So it got me thinking, can I send them unicast? Oh, no, the spec says no in a big red must. So because in Babel, hellos did 2 things. One was discovery of the peers, which really needs to be multicast, and the other was link quality estimation, peer liveliness, and reverse reachability detection. Well, the forward part of that. Anyway, so I was thinking maybe if there could be a way to kind of split those 2 apart, that would be really neat, especially when you have link layers where you can get discovery of the other nodes through some out-of-band mechanism. So that's kind of where this started. And then this is applicable only so to links where multicast sucks, to links where there is no multicast, and also to if we start wanting to build security, and a lot of the security mechanisms that exist today don't play nicely with multicast. It's a one-to-one relationship, and the keys are often that way. In that case, it makes it a lot easier to do everything over unicast. So that's kind of the general idea on why I think this work is important. Next slide, please. So problem statement, and the reason that the original spec doesn't, well, says that you must send hellos multicast is that they have a sequence number and an interval that correspond to all the neighbors on the link. So anytime you send a hello, you need to increase the sequence number. You can't just send it to 1, then bad things will happen. So that's the hello TLVs for those that have forgotten. But the great news is there's 16 bits of reserve that could always come in handy in here. So next slide, please. the way we built the solution is to just rename this reserved field to flags and take the first one as the unicast flag. And then what this means is that instead of having a sequence, well, what the flag means is if it's not set, this is the multicast hello. If the flag is set, this is a unicast hello. So multicast hellos are exactly like the previous ones. They're backwards compatible. They work fine. And the sequence number that they carry applies to this link. Sorry. So you're sending it to all neighbors on this link. And the interval is a promise that before that time expires, you will send another one. The unicast flag on contrast means that this is a unicast hello. So conceptually, it is designed to you specifically, and the sequence number is specific to you. So then I can send one to neighbor A and one to neighbor B, and they can have different clocks. They can increment at different intervals, so they increment at different speeds. They're completely independent. Yeah, so both Sequo and the interface, let's stick to those. Next slide, please. In terms of what this means for interoperability, if you only send the multicast hellos, we're still in spec with 6126. What is necessary for this to not break the network, as Joe was saying earlier, is that nodes need to understand the unicast flag. The problem that arises if you don't is that you could end up seeing hellos with multicast and hellos with unicast with like two sets of sequence numbers. So instead of having something that increments slowly, it's kind of jumping back and forth, and that can really throw off your link estimation costs. So that would be kind of subpar. So what we mandate is that if you see a unicast flag, you need to understand it. So one simple solution is you see a unicast flag, you drop that hello, and that makes it very similar to the previous behavior, or at least if you don't know what that neighbor is saying, you will kind of completely ignore him and not establish neighbor relationship. So at least you avoid other problems. The way it's currently written in the spec is that you need to understand both, which I think is a good solution, but that gives us a transition path. Also, it's not mandated to send both. So implementations that today just send the multicast ones are still in spec, but implementations that for reasons of what links they're using, whatever, only want to send the unicast ones, that's still okay. You could end up in this case where some nodes that only do send unicast and some nodes that only send multicast on the same network, those will still interoperate if they both understand both. Next slide, please. So what do you need to actually implement this? It was surprisingly short once I actually got back into it. So for the multicast hellos, you need a sequence number for yourself per interface and an interval as well. And then for each neighbor, you need the sequence number and the interval from that neighbor in the neighbor table. What this adds is now in the neighbor table, you also have your outgoing sequence number unicast to them and the incoming unicast sequence number and interval from them. That's all you need to add. And also when you're computing the cost, you can react differently whether it came over unicast or multicast, because like ETX, for example, was designed for the multicast properties of 802.11. Next slide, please. And that's mostly it for unicast hellos. One interesting problem that came up was there are cases where you want to send most of your hellos using one methodology. Let's say you want to send most of them using multicast, but every so often you want to send one unicast. In the previous spec, if you did that, you had to send one with a very long interval and then keep sending them. So in order to make that a lot easier, we introduce what we call unscheduled hellos. And what those are hellos with an interval of 0. So since the interval is defined as, I really promise to send another hello of this type in this time frame, when it sets to 0, it means I'm not promising anything. I'm just giving you this hello. One of the main use cases is for the sub-TLVs for extensions. When you send those, you still increment the sequence number, though. In some of these cases, it actually doesn't matter, because if you're just using it for, let's say, the RTT information, for the RTT extension, you don't need it. But it's still, that was a decision we could have gone either way. We decided to go with this one. And the unscheduled hellos, you shouldn't necessarily use them for the neighbor acquisition, because you have no way of telling if the neighbor went away, if there's no interval that they told you they would send you something in. So they're really kind of used as this side mechanism if you still need a hello TLV for the sub TLVs.
Julius Krobachek, that's not part of the document, that they should not be used for neighbor acquisition. And there is nothing preventing you, just after you've received an unscheduled hello, say to send a unicast hello to the guy you just learned about. And does that count as neighbor acquisition? I'm not quite sure.
Fair, absolutely fair. The document does say, though, I think, unless we edited that afterwards, what it did say at some point was that, what the document said before is that if you don't see any hellos from a neighbor for a while, you must set the cost to infinity and forget it. And I think that what the document says now is that if you don't see any scheduled hellos for a while, you do the same thing. So if you only ever received unscheduled hellos, that's not good enough to establish neighbor. Is that what it says now, from memory? Julius, does that sounds right? Okay. And yep, that's it on scheduled hellos. And next slide, please. And that's all I have. Any questions? Thanks for your time.
Oh, actually,
We do have questions. Go ahead.
No.
Sorry, don't run away.
Please, questions. I'm sorry.
Hi, John Dowdle, Airbus. Quick question. So on the so presumably when you're multicasting hellos, new neighbours could arrive at any time, and therefore you should never really stop sending multicast hellos. If you send a unicast hello and somebody responds, does that mean that the job of that hello is then done and you stop sending hellos, apart from your unscheduled thing that you said just now?
It depends what you're trying to do. If your only way to discover the peers is with multicast hellos, which is the case for most deployments of Babel today, then you keep sending them, because that's the only way if two nodes come up at the same time, it's the only way they'll know about each other.
Okay.
However,
it's unicast. If I said hello to you and you said hello back to me,
yes.
if I keep saying hello to you, you're going to get confused, surely. Unless I'm doing a
So
hello to everyone.
No. So I don't get your question, because you keep sending hellos periodically in Babel.
Okay.
It's not a one-time thing. You keep, to have a neighbor, you need to keep receiving hellos from them. And when you receive hellos from them, you need to reply with I heard yous. So if you keep hearing hellos and I heard yous from a neighbor, you know they're there. It's not maybe hello is not the right
So
name.
not
But
moving
that's
to the
ship
next.
that has sailed a long time ago.
Cool.
Yeah, it's a periodic thing.
All right. Okay.
So I have two comments. One thing you didn't mention is that you are allowed to send multicast hellos over unicast. And that's an important point, and that's something that was explained to me by Margaret because I didn't realize it. So 6126 says that that hellos must be sent over multicast. And Margaret noticed that actually what I meant to say, reading my mind, thank you, Margaret, is that a hello must be sent to all neighbors on a given interface, because there is just one SecNo counter. And in particular, nothing breaks if you send it to all neighbors over multiple unicasts. Okay, so the new version, 6126 bis, says that multicast hellos must be sent to all neighbors, either over multicast or over an exhaustive set of unicasts. And given that, I'm not quite convinced that just this observation is not enough to solve your problem. And so I keep wondering, I lost a lot of sleep staring at the text while we were editing it, and apologies to everyone who was fed up with our spamming as we were discussing textual details. I spent a lot of time thinking, is it worth the complexity in this case? The other comment I'd like to make, which makes me a little bit uneasy, is that we are contradicting ourselves. There is text that belongs to you that you wrote that says that you must parse both kinds of hellos, and text from me that's in a mellow manner says, actually, if you really insist, you can ignore unicast hellos. We're not contradicting ourselves technically, because what that means is that you must parse the unicast hello, and you're only allowed to drop it after you've parsed it. But I'm not sure that was the intent. So I think we should spend some time during this week discussing all of those things. I'm not sure I'm entirely comfortable with the unicast hellos as they stand right now.
I actually think an offline meeting would be really useful for this outside the working group, because I actually have a lot of questions about the unicast as well that I'm not really straight on.
Sounds like a good idea to me. Cool. If that gets organized, please email or whoever wants to organize that. Julius, you're up. To organize this meeting, so we discussed this week, please email the list. So anyone interested.
Because I don't want to take up the whole this meeting.
To answer your first point, that is absolutely true. That's when I first when I first wrote up the proposal for unicast hellos, I called them, instead of unicast, multicast, I called them personal and public, precisely because they don't need to be sent over unicast and multicast, but that was gloriously shot down on the mailing list. So we went back to this, but there is that ambiguity, absolutely. One of the other benefits of unicast hellos is to allow you to have different intervals per neighbor, which, depending on how, let's say if it's a wireless link, how far they are, can improve your quality.
Yeah. So I think we're going to have a offline discussion and stuff of this. So basically what's going on is the talks are mostly, people are talking for the length of time allocated, and then the questions are expanding it a lot. So we're kind of running short on time. The next is the Babel information model by Barbara. And if you could run under time, that would be good. But
thanks, everyone.
As you should.
Okay, so we agreed at the last meeting in Chicago that we would make this a working group thing. So I, at the very last minute, remembered to upload a working group draft with just a couple of minor changes from Chicago. I noted in, I'm sorry, next slide.
That's okay. Yeah.
Pretty minor stuff. And then I added an open issues appendix. Next slide. And this is what I've currently gotten the open issues, mainly from discussion and from comments from Julius. Of course, the first one is that once we get all the Babel stuff stable, we'll need to go through and make the data, the information model match the draft. But it's sounds like there's still some instability, and so I'm not going to do that just yet. There's some other things that are pretty detailed, and maybe Julius will get some time to think about whether he really cares. The statistics and log stuff I think probably is important, and so in my next rev I'm actually going to start looking through and maybe suggest some possible statistics that could be collected. But that's what I have. Any comments? Really?
Yes, quick one. I think that in your second point that I wasn't radical enough, and that a lot of the list of things that are in your second point should just be flushed.
Huh?
Just be removed.
Oh, they were removed. You just asked. You should, in addition, after removing them, you said, but maybe they should be interface, but maybe not. And so, since that was a maybe not, I just left the question.
You were right. They should be removed.
Okay.
I was wrong.
Then we'll just take that issue off. One issue gone. That's perfect. I think that's it.
Okay, thank you.
Okay.
Good. Let's see. So the next thing here is the here, and that would be. I don't know why when I. Sandy, are you here? I think she was. Well, we will go on to the next one for right now, and we can go back to this source-specific routing.
Okay, so hello. So I will present you the update to source-specific routing with a metadata bit in Babel. Next, please.
Oh,
Okay, so just a few backgrounds. The source-specific routing is a routing paradigm which extends next-stop routing, and where the routing decision depends both on the source and the destination address of the packet. So routing tables maps pairs of prefix to next-stop, and its main use case is for host-centric multi-homing. So we're using prefix aggregate table addresses. Next. So the natural solution for Babel is to add a source prefix to any data structure and also to message. But the most important problem is that the source prefix cannot be just dropped for an update. Otherwise, you may have routing loops. So the typical example is that when you have a source-specific router which has a specific route, a legacy router, if it drops the source prefix, will announce a different route, and then you will have the routing loops. Next, please. So the previous version of the draft were using 3 new TLVs, and this new draft introduced only one sub-TLV, the source prefix sub-TLV, and you see that it's very simpler. Next, please. Of course, 6126 doesn't handle mandatory sub-TLVs, and so a legacy Babel router will drop the sub-TLV, and we have the example seen before, and causing a routing loop. So this extension is incompatible with 6126. Next, please. So about implementation status, it's implemented, it works, and it uses currently an experimental sub-TLV. Next, please. So one of the main remaining problems is about wildcard requests. So 6126 says that wildcard requests a full routing table dump. But the problem is what exactly means a wildcard request. I mean, in 6126, so a legacy router only knows routes which are not source specific. So when he says, give me a full routing table dump, he only requests for legacy routes. So the question is, does it, if we send all routes, included the source specific one, does we break the semantics or not? And if we send, one of the problem is, if we send more routes, is there a big waste of the bandwidth? So, and the third point is a technical detail, which we'll see afterwards. Next, please. So there has been many proposals, and there is 4 kind of proposals. So the first is, okay, we request a full dump, we send a full dump. The second is to say, we will request exactly what we want, and we will receive exactly what we want. The second is a slightly is a compromise. We only say here are my extensions, and we receive perhaps some waste route, but normally not a lot. And the last proposition was to deprecate wildcard request. Next, please. Next, please. I will skip this this slide, and we can come back. It's the detail of our proposal. So another thing was about wildcard updates. So wildcard updates is in fact a wildcard redirection. So it's not the same problem, because typically it's when a router shut down, it sends a wildcard redirection. So of course, source specific routes must be retracted too. So I think there is consensus that there is no need for source-specific wildcard redirection. Next, please. So as a conclusion, so thanks to mandatory sub-TLVs, because the extension is really simpler, both the code and the spec. It's implemented, it works, and now there is something to fix. So first, to choose a sub-TLV number, so for example, 128, and also chose a proposal for source-specific request. I personally like the simpler one, which is sending a full dump. And finally, I would like to request the working group adoption for this draft. Thanks for your attention.
Okay. Are there any comments on this? No.
Secretary Highland Jacobson, I also like the just dump everything option.
Yeah.
David Skenazy. So first off, great work. I really think the working group should adopt this. It makes sense in the charter in my mind. I was one of the ones loudly complaining about the full route dump, and now that I've come to look at the solutions and how none of them are like greatly satisfying, I can totally live with the full dump. It's probably not that bad.
Full table dump and adopt, please.
Okay, well, we will issue a call for adoption on the mailing list. I think this draft's been around for quite a while. While there's still some questions, it seems reasonable to adopt it if there's consensus on the list, so we'll ask for that. Thank you. Well, that's yeah, we switched order because you were out of the room when we got to you, so we did the other one. Go ahead. Yeah.
Good afternoon, everyone. I'm Sandy Zhang from ZTE. My presentation is about the update of beer in Babel draft. The first page is still the brief introduction of beer technology. And we know that beer is a new multicast technology, and they has many advantages. And it does not require a signaling protocol to explicitly build multicast distribution trees, nor does it require intermediate nodes to maintain any per flow stage. So, and we know that beer technology split the network into 3 levels. And the first level is the overlay and the beer transport level and the underlay. And we know that in order to forward beer encapsulate packet, some beer information must be transferred in the network. After the network runs Babel protocol as the underlay, as the routing protocol, and we can use Babel as also the underlay protocol for beer. So many beer key parameters can be conveyed by Babel protocol. Next. And we know that Babel defines this distance vector routing protocol that operates in a robust and efficient fashion, both in ordinary wired as well as in wireless mesh networks. And thanks to Ulyss for that, he introduced sub-TLV for our extension. So we can use a new sub-TLV for beer information transportation. Let's see that how to do that. We know that beer information includes BF ID, BFR prefix, and MPRS information, and BSL, and so on. And this information can be carried in Babel update message through the new beer info sub-TLV. And the mandatory bit, we know that it's a new bit in Babel protocol. So mandatory bit of beer sub-TLV should be set to 0. If a router cannot recognize a sub-TLV, the router must ignore the unknown sub-TLV. And so we know that we can use Babel protocol as underlay protocol of beer technology, and beer can build the forwarding plane according to the information that's conveyed by Babel protocol. And this is the underlay protocol of beer technology. And also we can use BMLD to convey the multicast information between each nodes. Then this is overlay protocol. Then the multicast flows can be forwarded from ingress nodes to egress nodes. The BMRD is a new working group documents in beer working group. Next, please. Let's see the format. We know that we can define a new type of beer sub-TLB for beer information in Babel. But we still have two associated sub-TLBs. But there is no sub-TLBs in Babel protocol. So how can we achieve the destination? And so the two sub-TLBs are carried as payload of beer sub-TLB. So the two sub-TLB will be encoded in the payload of beer sub-TLB. And so the length of beer sub-TLB will include the length of the beer sub-TLB itself and the potential length of the two sub-TLBs. So we can convey all the beer information in the network.
Yeah.
And we know that if there is many network that runs different dynamic protocols such as ECS, SPF, and BDP, and also Babel. So there is already ECS, SPF, BDP extensions for beer. So the three protocols can be used as underlay of beer technology. And also we think that Babel can be used as underlay protocol of beer technology. And we know that beer architecture does not rely on all routers in a domain performing BFR procedures. So how to support tunnels that will allow to tunnel beer across such routers in Babel is for further study. Because according to the previous slides, we know that if we can't support the beer sub-TLB, we will ignore it, and we will can't transport it to the other routers in the network. So it may be the beer forwarding plane can't be built in several nodes. So it may be a question. But we suggest that we can use we can update all the routers to support this extension and also the beer technology. So the network will not be a problem, I think. And this extension has been implemented. So you can find the information through that link, and the coding is based on the update version of FC 6126 bits on July 9, I think. June 9. I think it's based on the coding version of that. So you can, it's working. So any comments? And except that, although I don't know which group should this draft belongs to, so I think I must ask Aliyah for this one.
Aliyah Atlas. So I believe that this document should be in Babel if there is interest for it. The other IGPs, there's wide knowledge of how to safely extend those for OSPF and IS, and we have a good decade, well, we won't talk about how long we have an experience for extending OSPF and ISIS, but I think that Babel has still been moving and that knowledge is not as broad. Plus, I think that the set of people who will be interested and consider implementing it are here.
Okay.
So first, I think that's some very interesting work. from, so it's not necessarily interested from the point of view of the applications. My understanding of beer is that beer functions in a beer domain, which intuitively speaking, and I'm afraid because there are people in the back of the room I'm afraid of, but roughly speaking would be a data center and or an operator network. And I don't think Babel has been much deployed in this kind of environments. On the other hand, where it is very interesting is to see how difficult it is to implement beer with a distance vector protocol. If you look at the basic beer specifications, they assume that you're doing SPF. And as you pointed out, there is the example of automatic tunnel creation that really assumes that you have full topology. So how much of beer can you do when you only have the partial view that Babel gives you? That is something that needs to be checked, and you can do it with RIP, with EIGRP, and Babel. And I like EIGRP, but I prefer Babel, so I'm glad you do it here.
Yeah.
Okay, then I'll finish quickly. So I think it's very interesting work. There is one thing that makes me uncomfortable is your use of sub-TLVs. So we would need to decide what to do with them. As to adoption, I am not sure. There are a few extensions that we have that are mature extensions. Notably, the RTT extension is being deployed quite widely, and it still hasn't been adopted because in this working group we have been concentrating on getting the base protocol specification. Okay, source-specific routing is something of an exception because HomeNet needs it. So I'm not sure that, I have the feeling that adoption for now would be premature.
Okay, we have one person in the queue on network. I guess we'll go to them, and then that'll be it because we're essentially out of time. So I'm going to switch to Dennis now.
Hello, can you acknowledge you hear me?
Hello, yes.
Just one generic comment. I have quickly looked through the repository that's on the last slide or one of the previous, the one on GitHub, and in that repository all the previous history has been replaced with the initial commit. I think it would help to preserve the commit history of the work that it's based upon, so you can easier see what was in the source code and what was added later to implement the extension. That's it. Just that. Thank you.
Okay. Do you want to respond quickly, and or I don't know? You seem to be commenting that you should preserve the changes in the GitHub version. I'm not sure I understood his comment completely. But yeah, source code.
The main coding is in a separately C profile, so he can find all the detailed information in the C file profile.
Okay.
Yeah.
Okay, so we're kind of out of time. We should continue some of these really interesting topics on the mailing list, I think, and so I'll see you all there and at the next meeting, I guess. Thank you.
Thank you.
That was Dennis Obienko.